This is the FloriVoxTron, a sample playback-based synthesizer which uses subtractive synthesis techniques to modify the original sounds. The format follows a pretty standard flow of oscillator, in this case the Robertsonics Tsunami sample player, a VCA into a VCF, valve overdrive, and finally an effects unit. What I think is quite unique about this synthesizer is that the signal flow is stereo from the beginning to the end, and this includes how the modulators work. Working from the source, we have 4 voice layers: Eins, Zwei, Drei, and Vier. These being German for 1, 2, 3, and 4. Given that the sound source is sample-based, each of these voices can access any of the 120 sample sets. Each sample set has independent samples per note for the 36-note keyboard. Each of these voices contains a stereo VCA to control their level. Within these VCAs is also where we see the first use of the many modulators. The modulators are in essence pretty standard, but each one is actually 2 LFOs. The first one is sort of like a level LFO and the other a pan LFO, but that's not strictly how they work. On startup, the unit loads a default patch to set parameters to a usable position. Let's create a simple patch where we can explore each of the FloriVoxTron sections. By the way, the name is derived from one of my earlier projects named the FlorianVox, which was a nod to Florian Schneider of Kraftwerk, and this was a computer voice synthesizer. We will start with choosing a sample set. I'll choose a simple pulse waveform for this demo. I have all range of sample sets currently in the unit, and these may change based on their usability. A quick way of getting to each voice's sample set is to click once on the voice's encoder. The LCD now shows the current sample set for Eins. To change the sample set, we press and hold the LCD's encoder until the text color changes from blue to green, where we can turn the LCD encoder to change to a different sample set. When you have chosen the new set, press and hold the encoder again until the color changes back to blue. So here we have a basic pulse waveform. So let's have a play with this voice's VCA. I'll use its modulator to do a simple tremolo type effect. The modulator controls for all sections are in one module. The LEDs on the left-hand side show the module destination and also which LFO of the 2 we are using. The 2 touch switches can be used to cycle through the level and pan LFOs. The top one is the level and the bottom the pan. The level LFO is active when the LEDs are blue and the pan LFO when they are purple. The other way of activating the voice's VCA modulator is to either rotate its encoder or turn the voice off and on. The touch switch under the Eins encoder is the voice's activation switch. As we turn up the depth control on the level LFO, we hear the tremolo effect taking place. We can change the speed. Regarding the speed control, it does have a huge range which can be changed by invoking the multiplier value. Several controls have dual functions available. In the case of the speed multiplier, we press and hold the speed encoder. The LCD screen will change from speed to speed div. Here we can increase the value to output a higher speed LFO. Pressing and holding again will change it back to speed. We can change the waveform by pressing the touch switch to the right of the depth control. Each press will cycle through the 10 currently available waveforms. The LEDs at the bottom of the modulator will display the change of waveform except where we go to the user list of waveforms. This was a chosen method of being able to easily display the most common waveforms but allow for the addition of more waveforms later down the line without replacing the front panel. Next to the speed control we have the delay control. This is like having an attack and release envelope on the output, essentially delaying the start of the modulator's output. The delay control also has a secondary function, but I'll come back to this later. Continuing on, we have the res control. This is like a reversed sample and hold, or maybe a bit crusher. Taking the output of the sine wave, for example, we can hear how the waveform was broken up as we increase the res value. The res control has a secondary function which controls the pulse width of the square wave output. So now things get more interesting. We change to the pan LFO. This is done by pressing the bottom touch switch. The LEDs change to purple, indicating we are now controlling the pan LFO. As we increase the depth control of the pan LFO, we start to hear how what was essentially a mono tremolo signal become a complex stereo tremolo. What the pan LFO is doing is applying its own output to the output of the level LFO, but subtracts its signal for the left output and adds its signal to the right output. One of the added benefits of the pan LFO is to cross-modulate the level LFO. I'll turn down the depth control on the pan LFO so we can hear the effect more clearly. If we go back to the level LFO by pressing the upper button, the LEDs change back to blue. We press and hold the depth control and we get the secondary function, which is the cross-mod panner. By increasing this value, the pan LFO now modulates the speed of the level LFO. This is best demonstrated with the pan LFO outputting a slow sine wave. Another general encoder function to note here is that if we quickly double-click the depth encoder, it will change from its current value to full, being 255, and another double-click will set it to 0. This is a quick way of getting to either end of the value range. This applies to many encoders if it's an appropriate thing to do. For example, the VCF resonance control doesn't have this feature. So one of my favourite destinations for the modulator is the VCF. There are two Curtis Electromusic based boards here, configured as an Elka Synthex filter. This configuration allows for several different arrangements with just one VCF chip per channel. So to start with, I will turn off the tremolo effect. This is done by simply turning the 1 voice VCA modulator depth to 0. But before I do this, this is probably a good place to show a small feature. If you turn the depth of the level LFO down and the pan LFO up, you get a fully stereo effect. This is what it sounds like. I'll turn the tremolo off now. We now move to the VCF. There are actually two stereo VCFs in this unit. I'll backpedal a bit here. Voices 1, 2 and 3 are mixed together after their VCA to VCF blue and continue through the valve overdrive, another VCA named Meister, effects unit blue, and to the final mixer and out of the FloriVoxTron. Voice Via has its own VCF, which is the purple one, and also its own effects unit. The two VCF modules are configured the same. If you were to turn on Voice Via at this moment, the filter and the effects unit will change over to the purple one, indicating that their controls now control the purple signal path. The opposite would happen should you then change back to the other voices. To the VCF demo. The controls are pretty standard: frequency cutoff, resonance, and filter type. I'll choose LP4, which is a 4-stage low-pass filter. Let's start with turning up the resonance to about 100. This is where it almost starts to self-oscillate. The level starts to reduce and the sound thins out. Now I turn down the cutoff frequency to around half, which is 127. Over to the modulator. Turn up the depth control and we get that recognisable wah type effect. Let's turn up the res value too. a nice stepped filter effect is created. We could turn up the pan LFO a little as well. This would be a good time to introduce some echo. Over to the effects panel. The effects unit is an experimental noise FV1 module. These have 8 algorithms, different effects types, with 3 user controls. These 3 controls are controlled from the encoders labelled param A, B and C. In addition are the dry and wet controls, which control the amount of affected and non-affected audio going to the final mixer. Let's start with turning the wet control to about -6 dB. Since it's at -96, which is essentially turned off, I can double click the wet control and it takes us to 0 dB, where I can then back it off to -6. I'll select the tape echo algorithm. From here we can adjust the parameter values. In the case of tape echo, param A is echo time, param B is feedback, and param C is high frequency loss or dampening. I'll adjust these a little to help spread and smooth out the sound. Now is a good time to use that cross-modulation of the modulator for the VCF. I'll add a little of that in, and finally I want to turn up the resonance to where it just starts to resonate. Of course we could also modulate the resonance. We'll just do this a little so the resonating sound comes and goes. What's nice here is that without playing any of the notes on the keyboard, the filter happily plays away controlled from its modulator. Now would be a good time to mention that all modulators have an ADSR envelope generator. Let's use this on the VCF that we are working with at the moment. Making sure we are using the VCF cutoff frequency modulator, which we can select by either touching the cutoff encoder or using the modulator touch switches to change if we're not already there. Over to the envelope module. Let's set the attack to around 200. Now increase the depth control. For the ADSR to have full effect, you generally have to reduce the cutoff frequency on the VCF. Now we have a nice swelling up sound. I'll turn off the ADSR on the VCF and I will go over and apply attack and decay to voice 1. We select the modulator for voice 1 by touching the 1 rotary encoder. Now we increase the attack and release values on the envelope generator. The depth control on the voices has no effect. Now each note has its own attack and release cycle. The Tsunami also has the ability to do pitch modulation. This is actually its pitch bending feature, which I've taken further by applying a modulation to it. Only one voice can have pitch modulation at a time due to the slightly dodgy nature of how I make this work. To engage pitch modulation, we have to use the modulator touch sensors to take it to pitch. Then we do a single click of the voice 1 encoder. I'll choose the quad square waveform and a depth of 255 with a speed of about 13. Another function within all modulators is the key trigger mode. When engaged, The pressing of a note on the keyboard will reset the waveform to its start point. Let's try this out on the current pitch modulation we have operating. To do this, we press the touch sensor next to key and set it to trigger key. We'll choose a saw up waveform and a slow speed. As with most modulators, the pitch modulator also has an envelope generator. Firstly, I'll turn off the LFO-based modulation. Turn up the depth control on the envelope, turn up the attack to around 50, and you have a nice slide up to the note. Turning the release up to around 150 gives a nice release slide back down. Note that to get the correct pitch, you should have the decay and sustain at full. It's here that another function of both the modulator and the envelope is more obvious. This is the invert feature. By single-clicking the depth control, it will activate and deactivate the invert function, which simply turns the waveform upside down. This function is quite evident when used on the pitch modulation, as it changes the attack's effect from going low to high, and then with the invert turned on, high to low. I'll go back to a basic ramp waveform on voice, Eins, with no modifications. Let's turn on the next voice, Zwei, and we'll set the sample set to ramp, but the octave 3 version, ramp 3 oct. Now we have two octave notes together. Each voice comes with the ability to be delayed after a key press. I'll delay voice Zwei. If you click on the Zwei encoder, it will take the LCD to Zwei's main sample set. Now use the LCD encoder to go back to voice Zwei's delay. Press and hold to edit the value and change the value to 200 milliseconds. Press and hold to accept the value. While we are at it, I will turn the voice attack on Zwei up to 33. Now I'm going to turn on Drei as well. Simply select the touch switch below the voice Drei and we'll click on its encoder to take the LCD to its main sample set. We will change this sample to set 18, pluck to octave. As before, press and hold to edit the value, scroll to 18 and press and hold to accept. Let's delay this voice to 400 milliseconds. Again, scroll back 2 and we have the Drei voice delay. Press and hold to edit, change to 400 and then press and hold to accept. Now you should have 3 sequence notes, as it were, Eins, then Zwei, then Drei. At this point, it's worth pointing out that like many sample players, the FloriVoxTron has descriptors which detail how a sample should be played. With the FloriVoxTron, the sample sets can be looped, one-shot, and as played. Loop will loop from the start to the end of a waveform until a note off. One shot will play the whole sample from start to end, and as played is a combination of the two, where a non-looping waveform in this mode will loop around. All these modes can be manually bypassed with the play mode parameter within each voice. Interesting effects can be achieved by looping a one-hit sample, especially when the voice is put in the held mode and something like a reverse piano continuously loops. First thing is to change the mode of the sample set sequencing. We'll use voice 1. Press the 1 encoder. This should show up the 1 sample set on the LCD. Scroll back to 1 sequence. Change this to ascending. Now when a key is played and released, the next sample set will sound upon the same note being played. It is important to mention here that a sample set's change does not happen for every note at the same time. A note's sample set change is independent for each note. Now let's scroll through to all the sample sets for voice 1 and change them to the choir ones as mentioned. Change the 1 sample set to choir A. Scroll forward and change 1's add set A to choir E, and do the rest for the additional sample sets up to set D. Now when we play a single note, we can hear the change in the sample set each time. I think the most interesting feature of my approach is when you start to play chords, you get some interesting combinations. The best bit is you can do this for all 4 voices. To save time, I'll load in a demo patch where I have done this. While I'm in the voice module, I'd like to show the other 2 modes that the voices work in. The mode I've been using since the start of this demo is stack mode. This describes how each of the voices can simply be turned on and off and played at the same time when keys are pressed. Another voice mode is crossfade. This is where the fader comes into play. This mode allows you to select a set of voices at one end of the fader and another set on the other end. Using the fader, you can now crossfade between the 2 sets. This is how it works. Put voicing in the crossfade mode by pressing this sensor. You'll notice that the colour of the voicing LEDs are all the same now. Move the fader to the left. Now we can select the voices we want to hear when the fader is on the opposite side. I'll select Zwei. Zwei's LED turns green. Now I'll move the fader to the other side and I'll select 1. 1 turns red. While I am at it, I will change their sample sets. Zwei I'll change to choir A and 1 to choir U. As I move the fader from left to right, I get a mix of the 2 voices. The other voicing mode is Roto. First up, change the voicing mode to Roto. Turn on voices 1 and Zwei. Choose sample sets for each of these voices. I'll choose a simple triangle waveform for each, but 1 will be a triangle 1 octave and Zwei will be a triangle 2 octave, meaning they are an octave apart. Now play a chord. As you can hear, we are slowly dissolving between the 2 voices. Let's change the speed and introduce some cross-modulation. So these controls are alternates on the voice level encoders. Press and hold the 1 voice encoder. Roto speed should now be displayed. When you put this encoder into alternate mode, It does the same for the other 3 voice encoders. Change the speed to 200. The VIA encoder is the Xmod depth and the dry encoder is the Xmod speed. Let's add some Xmod. Change the Xmod depth to 230 and the Xmod speed to 100. I'm going to show off now by putting modulation on both of these voices, which will give us some width. So I have added pan LFO to each voice and given them different speeds and amount. This gives us a wider sound image. I'll go further now. I'll modulate both the VCFs cutoff and resonance. Turn on the valve overdrive. Yes, there is a real pair of valves there. And to finish it off, I'll add some echo. Another controller on the FloriVoxTron is the joystick. This has 2 axes, the X and Y. Either of these axes can be assigned to a set number of parameters within the FloriVoxTron. The 3 buttons below the joystick with associated LEDs are user assignable parameters. By default, red is linked to the VCF blues, cutoff and resonance values. This should put an extra element to our already crazy patch. One last part of this full-on demo patch. I'll put on voice VIA for the first time. As mentioned earlier, this voice has its own audio path with a separate VCA, VCF and effects unit. I'll put a different type of sound on this voice. I'll choose one of the moving vowel patches I have. I'll leave the filter fully open and add a different echo effect. Now we have another layer which is clearly different from the other voices. VIA is still affected by the roto of the voicing module. I want to show how the stutter effect works. This is all about sample playback control. The main aim here is to introduce randomness to the playback of a sample to create interesting soundscapes. There are 3 modes: pause and continue, stop and start, and finally retrigger. There are 2 performance controls for this effect, which are speed and scatter. When in pause and continue mode, a sample playback is paused and then obviously continued. The speed controls how often this happens, and as the scatter control is increased, the randomness of the start and continue time is changed. VIA is the only voice that the stutter effect works with due to the complexity of the process. I'll choose a moving vowel sample set. Here's what that sounds like. It's easy to hear the changes over time within this sample set. I'll turn on the stutter effect and set the speed to 200 and the scatter also to 200. Here's what that sounds like. You can hear how the sample stops and starts. There's a click associated with it because the sample is being started and stopped at a non-zero crossing point. To take this further, I'll play a few notes with delay between them. Then I'll put the voice on hold. Let's introduce some effects. Now that this voice is in held mode, the keyboard no longer affects it, so I can go back to the other voices and start playing them. I'll choose another vocal sound. After all, this is the FloriVoxTron. But this time I will include a sample sequencing set. If we're lucky, no notes will get stuck. Actually, this is quite good sometimes. Randomness with some unpredictability. That sounds pretty good to me. That's about it. There's the system menu, which has more basic operations like load, save and clear patch data. You can set the MIDI channel of the keyboard and synth section separately, which I personally wanted for my own studio. The keyboard control can be turned off, which again relates to my studio setup. The system clock can be set here. There's a couple of functions relating to bugs in the system. One is for where voices get stuck on, and the other is for a total system failure, which sends a reset to the main CPU. The FloriVoxTron is a bit of an ongoing project where things may get changed as I use the machine more and more. I hope you enjoyed this tour. It shows you what you can do when you get a Tsunami sample player, quite a bit of time and some money.